All right, our first presentation is going to be by Andrew Bavernick from Tarleton State University. Before we begin, are the judges ready with their forms? All right, sounds good. Andrew, you may share your screen and begin when you're ready.
Alrighty, so yes, my name is Andrew Bavernick. I'm a master's student here at Tarleton State University. In my thesis, I've been researching drug pollution. It's detection, remediation of drug pollution and its effect on the environment. So honestly, this might be right up Ashley's alley. I know she's researching parabens. I'm researching more of the medicated stuff in the parabens. So I think she might get some enjoyment from this at least. So drug pollution, what is it? What does it do? Drug pollution is the contamination of waterways with pharmaceuticals and their metabolites. Some people think that excretion is a big factor to do with this. Unfortunately, we detected that about 10% of all drug pollution actually comes from excretion from urine or feces. We see more impact from improper disposals of these medications. We see lack of reclamation from manufacturing and overdosage and overuse of medications. I can't believe how many times I find people still surprised at the statement, but if you do not finish your medications, you can take them back to the pharmacy and they'll dispose of them for you. They have incinerators, they'll take care of it. We don't need to throw them in the trash or flush them down the floor. So what does it do? Historically, drug pollution has caused bird and fish kill. One thing in particular is the white rumped vulture, also known as the Asian gyps. We've seen it get critically endangered. One proposed method of dwindling of their population actually comes from kidney failure. We think this is actually from diclonophen, which is an NSAID. And we also see problems with fish kill washing up on the beaches, primarily off the shores of India. The current concerns of them are these medications are built for creatures much larger than these fish or birds. They aren't always nice. They're not isolated materials. They exist in areas with counterindicative medications. And they tend to be persistent throughout the water treatment and through natural media pressures of the environment itself. Why should we care about this? Honestly, I'm sad to say right now in America, we kind of don't. There's not a whole lot of information about it. It is an emerging contaminant. The EPA has recommended estradiol products to be regulated for multiple years now. It's just we've never really jumped on that trend yet. But just because we don't notice the effects in humans doesn't mean there aren't any effects. This does contribute to water scarcity. This growing problem around the world. I think I read that 200 million people worldwide suffer from water scarcity. So if we can prevent this mismanagement of resources, we might as well do it. There's also concern about superbugs. Multiple drugs such as azithromycin and penicillin exist in the waterways, and the soil microbes are being constantly exposed to this. They can build up a tolerance. They can transmit that tolerance to multiple species around them. And there's also the socioeconomic impact. People like to fish. I enjoy fishing. Some people, it's their livelihood. Some people do it for recreation. The zebrafish, we noticed within two generations, they're suffering from sterility from these estradiol products. So decrease in fish populations, more or less fish for people to catch. And also, there's a human decency method of it. Like, I don't know about you guys, but I don't want my dogs drinking, used medications. So this is where we start looking into how we can fix it. I chose 4 polymers extracted from locally sourced produce in whole form. I extract them under cold conditions because one of the compounds is horseradish peroxidase. I want to try and get that peroxidase out of the thing. But to precipitate out peroxidase, it needs to be cold. All of them are extracted under cold conditions just for uniformity. And in this, we are looking at Ristic Pharmaceutical Mix 1, which consists of the 8 pharmaceuticals shown on your right. So when we look at the actual remediation properties, we did 3 trials. We did a neutral pH, we did a basic pH, and then we also did a live water sample. I'm going to be going over the neutral pH testing for all the conditions, as well as a live water sample at the end. The remediation property of soy gum was the first one I looked at. As we noticed across the board, we have the determination of viscosity. We notice that it has an intrinsic viscosity of 4.8 milliliters, or sorry, 302 milliliters per gram, 18.5 milliliters per gram, and 297 milliliters per gram at 4.8 degrees Celsius, 18.6 degrees Celsius, and 50.2 degrees Celsius, respectively. We had four of the pharmaceuticals have non-detectable limits in our HPLC analysis. Out of the ones that were detected, we saw 97, 87, and 72 and 42% reduction of those analytes. The horseradish gum did actually pretty well at neutral pH. We noticed it had an intrinsic viscosity of 370 milliliters per gram, 727 milliliters per gram, and 188 milliliters per gram at cold, room temperature, and warm conditions. 6 of the analytes were actually in non-detectable conditions. One had a 98% reduction, a 92% reduction, and a 60% reduction. We had one unknown peak, if you look at the tail end of that graph, that tend to build up as concentration builds up. We believe that this is actually the oxidation of one of the analytes we were using that caused it to elute at a later time in the column. The flaxseed gum had intrinsic viscosities of 675, 168, and 444 milliliters per gram, as well as 5 non-detectable peaks in our HPLC columns. The ones that were detected were at 97, 96, and 85% reductions. The last one we were looking at was Ameligum. Those had an intrinsic viscosity of 31 and 41 milligrams or milliliters per gram. Sorry about that. At room temperature and hot temperature. However, we did notice it proved to be a solid under cold conditions, which, if we think about it, kind of makes sense. We use pectin and Jello, and it's kind of what solidifies it. And I didn't want to put a solid through my viscometer. We had 2 non-detectant detections in the phenobarbital itself. Out of the ones we did detect, we saw an 88%, an 86%, a 77%, a 72%, a 60%, and a 55% reduction in those analytes. In the live water applications, we see that most of them did a lot less optimal than in the isolated spiked solutions. We believe this is because of ionic contamination. Now, the ions will play a big effect into the tertiary and quaternary structure of these polymers. But when we look at it, we did still see remediation values. The flax did the best, which has been holding pretty strong throughout all the trials. It had 2 analytes with complete non-detection, one of 80% reduction and 2 of 60% reductions. The worst one we saw was a horseradish. It had 2 non-detections, as well as 142% decrease, 114% increase, and actually on the last peak, if you notice right here, we actually had a huge increase. About 68% of that peak height was increased. Once again, we think this goes back to the whole oxidation, and we chose the horseradish because it can oxidize. So we think that there were other constituents that eluted at that time, just caused by that oxidation reaction. Obviously, we're not done with this research. I would like to see more tests completed. We need to get more live water samples from other areas. Now, the live water sample I collected was actually from the Mississippi Delta. It was just right off the French border in Louisiana. It was a good sample, but just because that sample holds true doesn't mean it's the same way all throughout America. I would like to test this using different samples. The RISTech makes 2 other pharmaceutical mixes. One is a steroid, which is a big concern of ours because estradiol, the human remediation, like the amount we get to excrete in our urine is about 60%. So I want to see how these react with that as well. There's hundreds of polymers out there we can also try. I chose flax because it was nonpolar. I chose pectin because it was polar. I chose soy because of the tannic acid. The tannic acid makes it protic. All of these have different functional groups, which overall contribute to its remediation factors. The last thing I would like to look at is hybridization and optimization of these pharmaceuticals. Now, we did see pretty good results in our standard spike solution testing. However, just because we saw good results in that aspect doesn't mean it holds true. I want to know how we can optimize these, because ultimately the goal is to substitute out other compounds that we have, like polyacrylamide, which as we know, the acrylic anion can actually be carcinogenic in some cases. So if we can substitute out with a compound that has minimal to no effect on the aquatic environment, that's overall the goal. And I don't think we can ever make a true change unless we can prove that we can manufacture these pharmaceuticals at low cost and they have just as good as an impact. So to wrap it all up, I would like to thank, my school, Tarleton, for allowing me to do this research. I would like to thank you guys at Baylor for allowing me this chance to present my research to you guys. And ultimately, I want to thank the audience for listening to me. And if you guys have any questions, I'm opening to taking them now.
Very well done. You're right. I was interested, and I do have questions.
Sure.
So at what point in the wastewater treatment would these be applied? Are these a wastewater treatment? Are they something that you would try to just add as a step, or is it in the primary, secondary, or tertiary treatment?
So I like to think it will come in place in the primary treatment. As we all know, wastewater treatment usually starts off with the flocculation step. They dump a bunch of alum in the water to try and bridge the ionic charges and neutralize those charges. So if we can actually throw this in with the alum step, we have that flocculation goal. So when we mechanically sieve it through the filter, hopefully we'll trap a lot of those pharmaceuticals at the bottom. Now, the problem is that's currently what they do with polyacrylamide. But the problem is the polyacrylamide reclamation is never 100%. I've seen rates where some wastewater treatment plants accept reclamation levels of 80%. And as I said, those polyacrylamides actually go into the water. Ideally, they're supposed to be shelf stable, but they do end up breaking down to acrylic anions, and that's what I'm trying to eliminate.
Okay.
Any other questions?
Yeah, I want to say that was a good talk. It was really interesting and really good question, Ashley. I wanted to ask more about the methodology. I don't know if I missed it, but what instrument are you using to, get these peaks and to look at your analytes?
So it was reverse page HPLC. We were using a paracetal column. Our mobile solution was 50% acetonitrile and methanol. Now we had to do something a little funky with it because they weren't eluting at a normal peak. So we actually had to do, I thought it was interesting. I don't know how many of you guys are actually familiar with HPLC, but we had to do not only a gradient of the mobile solution, but we had to decrease the pressure on a gradient too, which is abnormal for most methods, but that's how we were able to get peak separation. Unfortunately, a lot of these compounds are very similar in molecular structure and they like to hold on to each other's peaks.
Great, thank you.
All right, thank you, Andrew. That was great. And our next presentation is going to be by Anshu Dandu from the University of North Texas. Before we begin, do judges need any more time to finish writing your feedback?
I'm just about done. Give me 2 seconds.
All right, sounds good. Okay, Anshu, you can begin sharing your screen whenever you're ready. Anshu, can you hear me?
Yeah, I can hear you. I'm just trying to figure this out
All right,
because my
no problem.
system's
You're
giving
good,
me
take your
trouble.
time.
Sorry. So my laptop isn't letting me share my screen. Do you think I could join in through my phone and share it from there?
That works, or you can email the presentation to me if you'd like, either way.
I can email it to you. Can you send me your email in the chat?
Sure, I'll send it.
Okay, I sent it.
Okay, you can let me know when you want me to change slides and stuff. You can begin whenever you're ready.
Okay. So hello, today I'll be presenting my current research that I have been conducting at the University of North Texas, which is about the diversity and abundance of North Texas tardigrades. So yeah, we can go to the next slide. So what are tardigrades? Tardigrades are basically these microscopic water bears that are able to live in extremely dry conditions and waterless conditions, which are like conditions that us humans can't live in ourselves. So even though there are a lot of tardigrades found all over the world, there's very little known about them and there's very little studied about them as well. So the purpose of our study was to investigate the distribution, diversity, and density of tardigrades in and around the city of Denton. So next slide, please. So in order to do this, we went around Denton and collected 15 samples at at 9 different sites. And can we go to the next slide? This is seen in this figure. So in this figure, there's a map of all the different sites that the samples were collected in. And there's also pie charts at each location to show the distribution of the different species found at each sample. So like if you see here, we have South Lake Park, and then we have a little pie chart that shows the distribution of all the different species. And the species are shown in the key next to the locations. So can we go back to the other slide? After collecting these samples from different substrates, such as mosses, lichen, and litter, the samples were dried for 2 days and then placed in distilled water in plastic cups. And we did this because we wanted, if there were tardigrades on the substrate, we wanted to like make them go to the bottom of the plastic cup. So when we extract the sample, it's easier for us to put underneath the microscope. So after doing that, we extracted using an Irvin loop, and we viewed it under a 30x binocular dissecting microscope. And these images were later, these were later imaged using a transmission microscope, which helped us with identification of the species. Because after we got the images, we looked at like the specific body parts, and we tried to identify what species it could be, because each species have different body parts and there's like distinguishing features for each species. Next slide. Again. One more. Okay. So the results of our study was that we found 365 tardigrades in 10 species. 62.2% of our samples had no tardigrades at all. 25.2% had only one species. 8.9% had 2 species, and then 2.2% of our samples had 3. And only 2 samples, which was 4.5% of our samples, had only 4 species. So in terms of species composition, abundance, and human disturbance, the community structure varied between sites with no patterns. But it was seen that North Lake Park, which is one of our locations, it had the most tardigrades, and the UNT campus had the least. We don't have a specific reasoning for this yet, but we're just assuming that the UNT, where we sampled in UNT, was near roads and not near the trees and stuff. So we were thinking it's probably because of human disturbance. But at the North Lake Park, we sampled near trees where there's like less human disturbance. So we were thinking that could have been one factor, but nothing's for sure yet. We're still researching about that. We also saw that the species Macrobiotis echinogenitus was the most common species, occurring in 77.8% of the sites, and the species Paramacrobiotis richtercis were rare, as they occurred in only less than 1% of our samples. Again, we don't know why this was the case, but we're further analyzing that. And then another pattern that we observed from the studies was the fact that there were more tardigrades in lichen habitats than in moss habitats. And there were more tardigrades detected on tree substrates than other substrates, which is different from another study that our research prof conducted, because in Chile, he's been sampling and he found that there were more tardigrade samples on moss substrates than lichen substrates. So there's a difference in our studies, and there's a difference in our results in both studies. So we're trying to figure out why that is again. So next slide. So again, we think one reason why we weren't able to find a wide variety of tardigrade species was because our sample size was too small, which means it doesn't represent the actual diversity of the tardigrades in real life. And then additionally, we think wind also plays a role here, as tardigrades are dispersed by the wind because they're so microscopic that they're able to travel by wind. And so we think that the upwind abundance of each species would limit the richness of species at specific sites that we were sampling at. So in conclusion, it can be seen that despite the great diversity among sites in our local investigation, it appears that some trends can be discerned and compared using a wider sampling approach in others. And again, we're still researching, we're still trying to find out what patterns there are and why the patterns are seen the way they are. But yeah, that's basically all I have today. So thank you for listening.
Thanks for the presentation, Anshu. I thought it was really interesting. I've never really thought about tardigrades. Like, I don't know. I always think about them as like the joke and not like something that actually exists in the environment around me. Have you guys thought about doing this in other areas of North Dallas, or like looking at wind patterns to maybe see if you can find an area where there might be a better species diversity?
Yeah, we were actually planning on looking at wind patterns really soon. We're in the process right now, but yeah, that is one of our things that we're planning on doing. And then we are sampling in other sites other than North Texas. My research professor goes to different countries to get different samples, and then we in the lab do all the imaging and extracting, and then we conduct data from that. So yeah, we are looking at other sites. It's not just North Texas, but this specific project was in North Texas to compare it to other studies. So
okay. I don't know where you guys are, or how you guys are doing your location selection, but I do know that there is a raptor center that's got a lot of land in Allen, Texas, and they really like when graduate students work with them. That's who has been working with me doing all of my samples for the last year. And it's an Army Corps of Engineers like site, so they may let you go out and like do sampling out there if you were interested.
thank you.
And then I think we've got a question in the chat from Andrew.
No, we have not considered any bioinformatics yet. Again, we're still like trying to figure things out because we're not sure where to go next, because we don't have enough information from other studies, because not many studies were conducted. So we're still trying to figure out where to go. But I mean, we probably could use bioinformatics, but as of right now, we have not considered it.
Are there
Just
any
a-
more questions?
Okay.
Go ahead.
Yeah, I liked your talk. I think you did a really good job with your data analysis and discussing kind of what that data means. My question was going to be along the lines of the sampling sites of what is your rationale? I know you want to look at North Texas, but those specific sites within the city, how do you guys choose where you're going to sample?
So we first sampled UNT, and we saw that there weren't enough tardigrades found, because I think we only found one tardigrade at our UNT sample. So from there we were like, so we tried to see why that was the case, and we thought it was the human disturbance aspect. So from there we looked at locations where there were more trees, or where we found less human environment going on and more like nature. So we went from there, and then at the same time we also looked for places where there were or like after we got to the site, we looked for places where there was less shade, because that was also another thing we were considering while researching about the tardigrades. So that was another criteria that we used. But other than that, I think the site choosing was like a bit random. It was just we were trying to get a whole aspect of Denton. So we were just finding sites that were kind of apart, but like in the same area. So.
Awesome. Thank you for the explanation.
Mhm.
And then I have another follow-up. Is there a specific like time of year or season when you are doing this sampling? Have you seen any patterns, like a seasonality aspect to your results?
As of right now, we only did one in the summer, but we're planning on doing them based on seasons soon. We haven't seen any patterns as far as I know about based on season. But again, we have to research more and to get to that conclusion. So.
Of course, thank you.
Mhm.
Okay, thank you to all the presenters. You all did a wonderful job. And this concludes the Integrative Environmental Science Division. We're going to take a picture of everyone involved in the division for social media. So you guys can do your school sign. Baylor can do SICM.
Definitely didn't go here as an undergrad, and I have no idea what that is.
All right. Okay, awesome. And judges, you can stay on the Zoom call to review comments and deliberate. Awards are going to be announced after the keynote speech today, and feedback will be emailed after the conference is over. The next event is the Graduate School Fair, which is at 11:15 a.m. So you can now leave this Zoom call and refer to the program link to find the link to the fair. Thank you so much.
Thank you guys so much.
Thank you.
Did he say he was a master's student?
Yeah, that was my first comment that I wrote was I thought it was
Yeah.
yeah.
I wonder if it was his undergraduate research and he's just now a master's student. But I was a little
Possibly.
thrown by that.
Yeah, I don't know. Yeah, I don't know about that. So for the two talks, I thought that Andrew did a good job with his intro and really explaining the justification and significance for his research.
Yeah.
I think he could have done a better job with the data interpretation.
Yeah, he didn't really explain, like he kind of